Hey there, calculus class. I am here to explain certain problems on the chain rule homework, and I'm going to start with number 4. So we have C of D equals cube root of 5D squared minus 1. We're supposed to take the derivative of that. So when you do the chain rule, you have to identify the inner function and then treat it as though it's just a big old X. I just actually think of it as a blob, because it's my usual language. So when I look at this function, I see, let me get a different marker here. I see an inner function here, this thing, that I've taken the cube root of. So this is my inner function. So anyway, let me rewrite this. Since we're going to take the derivative, it's helpful to rewrite things in exponential notation rather than rational. So there I go. Now when I take the derivative, the chain rule says, take the derivative of the outside, but leave the inner untouched. So what I think of that as is, I just think of the inner as a big old blob, a big old X. I've got a blob to the 1/3 here. So the first part of the chain rule says, take the derivative of that blob. So, well, I'm sorry, take the derivative of blob to the 1/3 for our case. So I'll do that. I'll do the derivative of blob to the 1/3 is just 1/3 blob to the negative 2/3, right? Because when I do the power rule, I bring down the exponent and then I subtract 1. Great. Then the second and last step in the chain rule is then take the derivative of the inside. Take the derivative of that blob. So what's the derivative of this blob going to be? 10d. That's it. This bring the exponent down, 10d, and then the derivative of negative 1 is just 0, so it goes away. So can you clean this up a little? I mean, you can. If you put it in fraction form, uncollapse the fraction here, this would end up on the bottom because it's got a negative exponent. This would stay on top. This was already on the bottom. So I'm guessing the one slightly easier way to look at it, anyway, is that to the positive 2/3. Okay? Great. Let me do number 8 now. So number 8 says what is it? Y. Okay. Y equals e to the 2x. Gosh, I can't remember anything now. Minus 3. Is that okay? 2x minus 3, and then times secant x. So if you have your derivative goggles on, you have to notice that this is a product rule thing. So let me proceed with u's and v's. U is my first factor here. V is secant x. When I take the derivative of this, I have to do the chain rule because I have one function inside another. So that makes me think chain rule, chain rule. So my inner function here is this guy right there. My outer function is e. So when I take the derivative of the outer function, I just think of the inner as a big old blob, big old X. So I say, hey, first step, what's the derivative of e to the blob, or e to the x? No, it's just e to that blob, or e to that x. So my first step is just going to result in the same thing, and then times the derivative of the inside. So times the derivative of that thing there, which is just going to be 2. And then the derivative of secant is sectan. What do sec people do? They secatan, right? That silly memory game. So I'm just going to clean this up a little bit. I'm just going to move the 2 over there, so that's just the same as this. And then when I do left-facing fish, I'll have y prime equals this diagonal, so 2 secant x e to the 2x minus 3. Not sure if I should have really. Oh, that's fine. Whatever. And then plus, our product rule says plus this thing. E to the 2x minus 3, secant x, tangent x. Shazam. Okay? Okay. Let's do 11 now. All right, 11. Oh, it's a second derivative. So we need to find d squared dy squared of, what are they doing this? X squared plus 1 quantity cubed. X squared plus 1 quantity cubed. Okay, well the first derivative is not going to be too bad because here is the inner function. So I'm now going to do just the derivative of, pretend that's a blob. So what's the derivative of a blob cubed? It is, I'll say this is y prime, okay? Y prime. I'm not actually seeing myself in the camera. I should probably do that in case I'm shielding you. Okay. 3 blob squared. And then the chain rule says, now that you've done blob cubed, now multiplied by the derivative of the inside. Bam. Okay. So I'm going to clean that up slightly because I have a 3 and a 2x there. That's just 6x. Plus 1 quantity squared. Okay. Now I have to do, take the derivative again because I need the second derivative. So I said in class that you've got a choice. Probably the smarter play here is just expand this guy, multiply it all by 6x, and then take the derivative. I'm trying to get you good at all the rules, so I'm actually, and I think in the answers, I did it as though it were product rule, because you could also do this as a product rule. So let me set that up, okay? Even though that's probably not the easiest way to do it. But if you see it, it's not wrong. So u equals 6x. Oh, and do you see it's a product rule because you have one function times another? So, and then v equals squared. U prime equals 6. V prime, chain rule again. I've got blobs squared, so it's going to be 2 blob to the first power times the derivative of the inside. And then if I clean that up a little bit, that's just going to be 4x, x squared plus 1. Okay? And then when I do left-facing fish, this diagonal is going to be 6, x squared plus 1, plus for the product rule. And then multiply by this diagonal, 24x squared times x squared plus 1. Okay? Shazam. All right. Number 12 is what I'll do next. Let me go back to that. Find the equation of the line. Okay, so let me just write this function down. Y equals 2 tan of what? Pi x over 4. And we need it right at x equals 1. Great. All right, let me switch back to the camera here. Okay, so I got to do point slope form. Y minus y1 equals x minus x1. But I know my x is 1. And I can figure out what the y is because it's the point is going to share the same, the point and the curve are going to share the same, I'm sorry, the line and the curve are going to share the same point, okay? So if this is at 1, I can figure out the y-coordinate of the line by just figuring out the y-coordinate of the curve. So in other words, put a 1 in there. So what is a tan of, look at this, you guys. It's just tan of pi over 4, right? Because that's going to be 1. And tan of pi over 4 is just 1. So what's 2 times 1? That's going to give me a 2 here, okay? All I need now is the slope of the tangent line, and that's just the derivative. So let's do it. Y prime equals, I can kick out the coefficient if it bothers you, right? I can just like ignore it for a second. I'm just going to leave it in here because I know that's what's going to happen. Now, the derivative of tan of a blob, see, I got to think of that as a blob there, okay, is secant squared of that blob. Times the derivative of the inside. Well, actually, let me just show you. You know how to do this, but I could see it being confusing. If you kick out the coefficient, can you folks see that this is just pi over 4 times x? Because if you think of it this way, it's way easier to take the derivative. Because this is basically just the same as like 7x or 12x or something like that. You're just going to get the constant as your derivative. So the derivative of that inside is just pi over 4. Okay? Now I need to figure out what the slope is, not at any x, but at that particular x, right, at x equals 1. So y prime of 1 is 2. Secant squared of pi times 1 over 4, and then multiplied by pi over 4. Secant of pi over 4, boy oh boy, what is that? Square root 2. Oh wow, this is going to be nice then, because check it out. You're going to get 2, then this is just the square root of 2, but guess what? It's squared, and then times pi over 4. Oh, they made this look nice, really. They made this work out really nicely, because that's just a 2. 2 times 2 is 4, which just equals pi, people. So what is my final answer? Bam. Okay, this guy right there. Okay. And then, how long has this been going here? 12 minutes. I should probably stop it.